Hello everyone. Now we're going to look at a function question. Let's get started together and see. For the functions f and g defined on the set of real numbers, the following equality holds. Accordingly, for which real number a does this equality hold? What is the value of the real number a? That's what they're asking. Okay guys, this part is a composite function. First, let's break this part down and see. F. A equals, guys, just like this, you see. G. A. Let's write our function, and we're done. Now, friends, an equality is also given here. First, let's take this and see what it means. Yes. 3 plus, guys, 2x equals. What is it? It's x. Look, what does it say in the definition here? It says the function f should be equal to a. So what does this mean here? It means make the inside of this a. In other words, set it equal to a. 3 plus 2x equals. We're supposed to say a, all right? We sent this over to the side. I'm going to isolate x, minus 3. 2x equals a minus 3. So what will x be here? It will be a minus 3 divided by 2. So guys, this part is supposed to be a. Did you see that? We wrote it down. What is it supposed to be equal to? To x. Isn't this already the value of x? So that means this part too, guys. It will be a 3 divided by 2. So this is what we got. This part was f of a, right? What is this part equal to? A minus 3 over 2. Are we clear? Good. Now, let's continue. Let's draw a line here. So, what are we going to do now, guys? We're going to take the expression here. Look, it was nested, right? What am I going to do? I'm going to take this expression right here and set it equal to this. So this time this will be a. Is it okay? So let me take the function g, like this. 2 plus x if equal to. It's x, friends. This will be a. If I set 2 plus x equal to a and send that over to the side. If I solve for x, x equals a minus 2, right? Good. And this is x, isn't it? Yes, so this part became a minus 2. All right. Let me show it right here. It's a minus 2, friends. See, we ended up with another g function again. Should I write it like this? It'll get a bit nested though. A minus 2 now. He says take this statement again. It should be equal to this, so it will be equal to the 1 here. So it's going to be equal to 2 plus x. How? 2 plus x is equal to. I was going to say a minus 2. Are we okay? Look again if I send this way. Minus 2. A minus 4. So the value of x equals a minus 4. All right? Didn't you just find the whole value here? What was it? A minus 4. Weren't these equal to each other? Yes, a minus 4. We're on the same page, right, guys? Here too, we do a cross multiplication. And that's the end of our question. Let's draw it like this, just to keep things clear. Imagine there's a hidden one underneath. 1 times a is a, 1 times negative 3 is negative 3, 2 times a is 2a. I multiplied 2 by negative 4, negative 8. Let's do this with a. Should I move 2a? I'll move this one. Guys, this goes over here as minus a. If you subtract a from 2a, you'll be left with just 1a. You move the negative 8 to the other side of the equation as a positive 8. Then you subtract 3 from 8, 5. So the value of a is 5, guys. Hi guys, now we're going to look at a function question. Let's get started together and see. What is the result of the expression? That's the question. Now, guys, we've been given a composite function and its inverse has been taken. First, what are we going to do? You're going to simplify the expression here. Now, the inverse of f's inverse, guys, will just be f. So we write the composite accordingly. Now I'm taking the inverse of g, guys, g. I closed the inverse. We're going to be asked for this expression. Pay attention here. It's still important. It's a composite function. Let's break this down right away. Together. I opened the parenthesis with f, closed it with the inverse of g, closed it, and what else is it doing? Basically, it wants the result of the expression here. Let's get started now. Which function are we going to use? We're going to use the g function, guys. Now, it wants us to take the inverse of g. Let's write g inverse and see. Close parenthesis. Guys, you're taking the inverse. When it was x minus 1, now it will be x plus 1. So, g inverse. Okay, g. For the inverse, which number's result did it ask for? It asked for 1. So, if you say g inverse of 1, meaning if you plug 1 in for x, the result here will be 2. Look, right here, it's 2. So, what does it want from you now? It wants the f2 function. We've come to this point. Friends, the value of f2. X minus 1. So what do you need to write for x to get 2? You write 3. So, in the end, this will be equal to 3. So, isn't that f 2? We write 3 wherever we see x. Our f2 value will be 3. Hello guys. Now we're going to look at a function question. Let's start together and see we have 2 of them. A function is defined like this, and we're being asked for the value of m. Okay, now friends, in functions we call this part the domain and this part we call the range. Are we clear? Isn't it the same thing here? This is the domain, friends. And this is the range. Now, here's what we're going to do. Look, you're going to set the domain equal. We're not going to just plug into wherever we see x. So, you're going to say that the value of x minus 2 will be 2. Are we clear up to this point, guys? Okay, let's move the 2 to the other side, so it becomes plus 2. What value do we get for x from here? 4. So, it's saying that now you can write 4 wherever you see x. Are we good? Great. Let's take it, friends. For example, let's think of it like this. The s function, s. 4 minus 2 is equal to. Guys, where I saw an x, I wrote 4 plus 4 and it became 4 plus m. Look what came. Pay attention like this. I subtracted 2 from 4, right? 4 plus m. Didn't the guys already say that the f2 value is minus 1? So this expression is equal to negative 1. What does this mean? This means that this part is also equal to negative 1. Okay, so I've set this equal to that as well. 4 plus m equals. It's negative 1. Let's move the 4 to this side. Let it go as minus 4. M equals from here, guys. It will be negative 5. They asked us for m. The value was asked. In this case, our answer is negative 5. Hello everyone. We're continuing with functions. This time, we'll look at a question about inverse functions together. Let's get started and see. In the one-to-one function f, 2 functions have been defined for us, and one of them is given as the inverse function. Given that, what is the value of m? Okay guys, in order to properly talk about the inverse of a function, the function absolutely needs to be one-to-one and also on 2. Are we clear? Let me mention that as a note for you. So, how will you fix this inverse function? Look, they've done these by taking the inverse of a function. So then, normally, imagine that we're going to take the inverse of the function again. Alright? If you notice, these two, the domain and a range, have switched places. So, the inverse was actually taken by swapping them. So, when we take the inverse of the inverse, meaning when we turn it back to normal, what do we do with the domain? We'll put it back where it was. So, it will be f7. And you'll swap the range with 7 as well. Let's send it back to where it was. It will be 3m minus 4. Awesome. Look what we got here. The f7 function equals 3m minus 4. Isn't the f7 function equal to 2m plus 5 again? So, these two expressions will be equal to each other. Let's set them equal. 3m minus 4 is equal to 2m plus 5. Let's send m to this side so that m. Let it be minus m. We subtracted 2 from 3. There is 1m left. You send the minus 4 to the other side. Plus I collected 4. 9. He asked for the m value. M will be equal to 9, guys.